Welcome everyone to another topic, bit magic. So we're going to start with the first question. Find first set bit. Have a quick look at the question and we'll be discussing the approach. Now coming to the approach, here you can see 18 in binary means 0, 1, 0, 0 and 1, 0. Okay. Now what this question is saying, we have to get the first LSB number which has one integer. What I mean by LSB? LSB is the least significant digit, right? This is LSB. LSB means least significant digit. By LSD means that we have to find from the right side of the binary number. Okay, from right side in this question, from the right side we have to get the first value where it is 1 bit. Okay, now here the first value is 0. We don't want 0, we want 1. So in the second, right, this is the second position. In this second position we have one value. So this is what we have to return as the output, the position number, which is 2 here. So this is what we got in the output. Now let's see how to convert a decimal to binary. So there are two ways. One way is a classic method where we have to take the LCM and divide again and again by 2. Like in this, let's divide it using the LCM. So 218, right? 2 nines are 18. So take the right side value 0 here and 2 fours are 8 here and remainder will be 1. Put the remainder right side here 1 and 2 twos are remainder will be 0 here. That will all the remainder will be again in here 0 and 2 and the 1. Okay, if you notice when we divide with 2 there will always be 1 here or 0. It may end with 1 or it may end with 0. Okay, if it ends with 0 there is no problem, but if it is ends with 1 we have to be careful. So in the loop that we are going to use a loop, inside that we will take as a 1 as a condition and implement the loop. Okay, you will understand why I am telling 1 is a little bit why we have to consider 1 here really carefully while we are implementing code. Okay, we'll be using the first basic method. Okay, this method we'll use. Now if you turn around this, now you can see 0, 1, 0, 0, right? This is the code 1, 0, 0 and 1, 0. Okay, from bottom to top we got the 1, 0, 0, 1, 0. This is the same one, but there is extra 0 here because in the question also we got an extra 0 on the left side. You can put as many as extra zeros if you want, but we're taking one extra 0 here because of the coding question problem, and we will be understanding in a little bit. For now, just think we got a binary number 0 1 0 0 1 0. Okay, now we have to store these numbers in a list, and you can store it in any list. Okay, you call it T, and we have to store the value. If you are doing this one by one, like if you're dividing and then getting reminder, then you will be storing values in a list. Okay, first you will store 0, then 1, then 0, and again here from top to bottom we are storing in a list from top to bottom while we are doing LCM. Okay, while we are doing LCM we are storing, but reverse is the answer. Okay, reverse is what we get the binary value. From bottom to top is the binary value, but while storing inside the code we're using list. So inside the list we're storing from top to bottom, and I told you in the question here we are going to take the least significant digit, right? One advantage while storing this in top to bottom is we have to find the first significant digit which has one value, right? So if you are storing from left to right in the list, so this is the least significant. This 0 is the last digit, sorry, this 0, and this one is the second last in that binary. So while we are using the list, those values will be stored from left to right. While we store left to right, then we can use a loop for loop here. After getting the binary value and stored in a list, now we will loop through this list. When we loop through the list, then we put a condition if t equals to, if t index I equals to 1 or not. If it is 1, then we get the index value which is I here, but we don't want the index value, we want a position value. So just add 1 and we will return this. We'll return this value after looping through the list of the binary numbers. Okay, this is one way to do it. We can use this method and we can divide and take the remainder and store it somewhere and replace the number every time by modulus. We'll see this in a code in a bit. So this is one classic method. Other method is there is a code in Python when we can use binary function here. If you use binary directly, bind of n, then it will also give you the same value, but you will get 0 and b at the start. Okay, we get 0 b, then after that this will be there 0 1 0 0 1 0. This will be combined with 0 b, so we have to remove these two. Okay, but even if you don't remove, in this case we won't have any problem because we have to check from the rightmost side, so this won't create any problem if we don't remove 0 b in this. So for this we have to convert this binary number, because it will be a single value. 0 0 1 0 0 will be a single value. We have to convert it to a string. After converting it to a string, then we have to loop through it like below here. We have to loop through that binary number after converting into a string. Then we can iterate and guess if the one character is available or not from the rightmost side of this. Okay, remember always from the rightmost side we have to get that. You can now you got the value directly 0 1 0, but now we have to get 0. So this time we will reverse this list. We will reverse this in this case. When we reverse, we get the same value as the t here. If we don't reverse, we will get this 0 1 0 1 0. In this 18 case, both are same, but for different value, it could be a different binary number. Okay. So this is the logic behind this question. Now let's go to the coding part. You will understand it more clearly. Now we are inside the Geek for Geeks website and the code has been already implemented. As we were told, we are using the basic method. We are dividing the two and storing a reminder values inside a list here, which is t. We are storing the reminder values of 2 one by one as we have discussed. So when the values have been stored, we will loop through it at the last. Okay, this while loop is checking the condition, as we have seen in the LCM, that we are getting one value. Okay, there we may also get zero value after one, or we may not get. Okay, if we got one value, then we have to add a zero according to the question, because question is considering a zero value, one zero value extra. So we are adding it here. And another case here again we are checking n equal to 0 is because 0 can be an input, right? 0 can be input. If 0 input we got directly 0 as an input, then there is no significant bit. If there is no significant bit, we return 0 here. If the value is greater than 1 or equal to 1, then we will loop through and then we store that reminder inside the t. For storing a reminder, we use n modulus 2. And now we are replacing the number n divided by 2. Like in this case, 18 was there. Now 18 by 2, we got 9 here. So now n will be equal to 9 in another iteration. Similarly, n 9 by 2 and that will become 4, then 4 by 2. Similarly, like that it will continue till we get the value 1. After getting the 1 value at the last, then we store the 0. Then the binary representation will be completed. Now we will loop through it, and we are not looping through in reverse order because we are storing it from top to down. So top is the least significant bit. So we are just directly looping through it. Now we got if we get the value 1, we can return that value here. And count I have initialized with 1. I have already taken as 1 here. We are not starting with 0 here. Now whenever the loop is coming, the count value is updated. Even if you don't use count, you can just directly use here x plus 1 also, that will also work. And now another condition is count is equal to length of the t. If it is equal to length of the t or not. Why this condition? Because if we are looping through the whole loop, right? If we loop through the whole loop, suppose this has 1 2 3 6 digits, means 6, length is 6. Now if we iterated through the whole length, now we didn't find any one value, then there is no significant digit. So this is a condition that ensures that we have looped through the whole loop. After looping through, we got the count value as the same length. That means we looped through it. We didn't find any one value there, so we're returning 0. So this is the logic behind the question. Let's see you in the next question using the bind bin function. Thank you for watching. If you like the video, please share and subscribe. And if you have any extra email IDs, please do subscribe. It will help us our channel to grow a lot. Thank you for watching. Let's see you in the next question.